Good evening, boys and girls. We're going to take two. I did the first video, way too many mistakes. I was saying three-dimensional and two-dimensional images, and there was a couple ums, so we're going to try to clean this bad boy up. All right. Tonight we're going to be talking about the area of a parallelogram. In the past, you've talked about the area of a rectangle or a square. You know that the area is just talking about the center of a three-dimensional image. So whenever I think of area, I think of an area rug, and that's going to take up the center of the floor. So I'm sure if you looked around your house, your parents probably have area rugs in the living room or in the kitchen, and they take up this center. All right. So when finding the area of a rectangle, for example, we're talking about everything in here. All right. And in order to find that, we would do the base times the height. All right. Now the nice thing is the area for a parallelogram is the same exact thing. So not too much information, as far as the formula is concerned, but we are going to have some new information as how we interpret the three-dimensional image. All right. So area base times height of a rectangle, area for a parallelogram, same formula, base times height. All right. So let's take a look at this example first. And the first thing we're going to do is classify whether it's a parallelogram or not. So what I like to do is, and you don't have to write this down, you can do this in your head, is if I were to extend this side out and go to the opposite side and extend that out, they would never touch. It means that they're parallel. So those two opposite sides, because they never meet, so far so good as far as meeting the criteria to be a parallelogram. Now we have to check the other set of sides. So we come over here and we extend these sides out. They would never touch either. So because two sets of opposite sides don't ever touch, they're both parallel, we're good to go. We know it's a parallelogram. All right. So we want to find out what's the total amount of meters, and I'm getting meters from the example, right? They tell us what the unit of measure is. The total amount of meters for the inside of this. So we're going to have area equals base times the height. All right? You can think of the base as the feet. They are what the image is resting on. Okay? So when we look at base, we want to think, if we were to set that bad boy on the floor, would it be flat? A lot of times we can tell that if it gives us a right angle symbol. So that'll tell us that it's 90 degrees with the floor. And right here, it gives us the height of 14 meters. Now, ladies and gentlemen, be very careful with this example. Sometimes, to be tricky, we'll have problems that will give us the height of 14 here, and then they'll have a slant over here of, say, we'll just put 15 for this example. All right? Now, the reason this is tricky is because sometimes students will plug that 15 in for the height. But I always like to use the example of myself. When I go to get measured for my height, they start at my feet and then they go straight up to the middle of my head, and it's a straight line from the floor all the way up. If I went to the doctor's office, they would never measure me from my head and then go at a slant down at an angle. All right? Same thing you can think of like a ladder. If your family is putting up lights, say for the holiday season, and this was the top of your roof, you wouldn't measure the height of the ladder from the slant. You would measure from the ground all the way up to your roof and say, wow, I'm that high off the ground. Okay? So this 14 is going to be our height, and we're going to plug that in. And our base is going to start from this point and go all the way over, and that's going to be 12. Once we plug those two in, we just multiply them together, and we have 12 times 14, which is 168 meters squared. A couple different ways I can remember if it's going to be squared or not. One way to think about this is it's 12 meters times 14 meters. Because we have that meter times a meter, we know that that would create an exponent of meters squared. You can also think of this as a two-dimensional image, so therefore we're going to have a 2 at the end of the unit. If it was a three-dimensional image, if we were talking about volume, for example, then it would be meters cubed, right? Because it's three-dimensional, so we put a 3 at the end of that unit. All right, now this example, this next one, is a little bit trickier. So pay attention. Here is our image, and we can see that we have that right angle symbol over here, and we have a 3. Now the 3 looks like the base, but in reality that 3 is on a slant, and it's kind of similar to that, how I put the 15 up there. Because we have this right angle right here, we know that we want that to be on the floor or the opposite of what would rest on the floor. Okay, so what we can do is we can actually kick this image and rotate it. That's the nice thing about geometry, is you can rotate these images, you can move them around to best fit whatever you're trying to find. And you can do that mentally too. Like Mr. Morgan, for example, on the Voyager team, he is really, really good at manipulating images in his head. Mr. Costal, not so much. All right, so we're going to kick this image down, actually, and we're going to make not a new image, but we're just going to make a new way to kind of think about this or represent it. And this is what the new image would look like. Now this example looks a little bit like the first one, all right? But we had to move it around, and we can see this is how I did it. I kicked this corner down to here, all right? And now we have a right angle symbol there. And it didn't give us this one, but then this opposite side would look like that. So we have that right angle on the ground. We know that these two sides are the same length because they're parallel. And we can see that our base is now 20. And our height is going to be this, from the bottom to the top, which is 7. All right? It's not 3 because 3 is on this slant. And 3 would be right here. So we have to manipulate this image, this parallelogram. So base of 20. Height of 7, I multiply the two of those together, and I get 140. I'm going to put a U for units because in this example it didn't give me feet, meters, centimeters, anything like that. So 140 units squared. All right? Try the examples, shoot me an email or a message on Schoology, anything if you have any questions about what we went over tonight in the video.